Welcome to the Virtual Pathfinder channel. This video is about planetary imaging, especially finding faint objects by star hopping from brighter objects. In this video, we use the bright planet Jupiter to navigate from star to find the way to the faint planet Neptune. Here's the content of this video. First, I say a few words about equipment. Then we move on to the use of STELLARIUM software to assist the star hopping. Then I will explain how I perform star hopping. And finally, I will show an example by star hopping from Jupiter to Neptune. My take on post-pandemic inflation is that it will likely overshoot, especially considering a likely 2023 recession. Prices may come down a bit after reaching a peak, but maybe not to the levels that was before the pandemic. So I would wait a bit before I see if I make any major purchase. There are other reasons to hold back too heavy investment in astrophotography equipment. One thing to consider is the number of dark nights with clear skies where the equipment will be used. Also, will the temperature be extremely high or low? In my case, the number of nights with good viewing conditions are very limited. In Northern Europe, summer nights are too bright for good observation. Midwinter nights are too cold. It is often cloudy and rainy during spring and autumn. The perfect conditions can only be found on a handful of nights, and as always, not all of these nights may fit your schedule of other activities. Having said that, once astronomical conditions are good, there is a need to have the best possible equipment to capture good images. My strategy has always been minimalistic, to buy as little equipment as possible, mainly use general photography equipment to get synergies and to get the maximum use out of each part. It is good to start small and scale up gradually, squeeze the maximum out of each configuration before upgrading. However, it's not a good idea to spend too little either, since that often has insufficient quality. And although it costs less, it becomes more expensive in the long run. While waiting for the inflation to come down, one way to do astrophotography is to use ordinary equipment such as an interchangeable lens camera with a telephoto lens or even a portrait lens. I have shot images of galaxies using a portrait lens. I made a video about that. If you have a stable photo tripod, a camera with a good lens, then there is only one more thing to add in order to do advanced astrophotography, which is a star tracker. The star tracker makes the camera rotate along with the circular movement of celestial objects caused by Earth rotation. With a good star tracker, it is possible to shoot long exposures without star trails. The long exposures gather a lot of light, which can bring out faint stars from the darkness. By stacking several long exposure images, it's possible to cancel out noise and bring out more details. As can be expected, astrophotography is not a spontaneous activity. It requires planning, careful alignment, and hours of image capture, and that is just the beginning. The raw images usually don't show much of anything before stacking and post-processing. In a way, it's good that there are cloudy nights as well, because during those cloudy nights it's possible to do the time-consuming post-processing part of the work. Although I love doing astrophotography, I cannot imagine any kind of photography that require a similar amount of patience. It is hard work, but it's also rewarding. Not everyone has the patience for it, so it's good to just dip the feet in the water before going all in. The price of equipment tend to increase exponentially with each incremental improvement of specifications. I see it as a challenge to take the minimalistic approach and only add new parts when I have stretched the existing gear to the limit. I started with the camera lenses before I bought telescopes. In this video, I have used a telephoto lens to shoot an image of Neptune. When planning or analyzing the captured images, it's good to have a STELLARIUM app. That will show the celestial object's location in the sky at each point in time. It is useful to set a scope display showing the field of view of the camera lens or a finder scope or telescope to get an idea of the scale of the image. If you don't know the scale of what you're seeing in the telescope, it's easy to get lost. When looking at a captured image of the night sky, it is easy to identify neighboring objects by comparing the telescope view and the stars in the circle representing the scope display. Unless you have a go-to mount, the best way to find faint objects is to locate easily identifiable bright objects in the vicinity. Then it's possible to use the Stellarium software as a map to navigate from star to star towards the target. In this video I have used an 85mm telephoto lens, which has such a wide angle of view that the bright object Jupiter is in the same frame as Neptune. Then one can do star hopping in one single long exposure image. Here is an image shot using an 85mm lens and a mirrorless micro four thirds camera. That corresponds to a 170mm lens for a full frame camera, which is a telephoto lens. The lens is fairly bright with aperture f2. Still, it is necessary to use a star tracker to be able to shoot an image with several seconds of exposure, which is necessary to capture Neptune. Let's start at the bright planet Jupiter and identify constellations of stars on the way to Neptune. First, there are some stars forming an arc and a line. In Sky Safari Pro Stellarium app for iOS, that configuration of stars can also be found in the image. That is the first step of the way. Moving on towards Neptune, there are 3 stars close to each other which can be identified. Then there are several relatively bright stars in the image which can easily be found in Sky Safari. Finally, at the very edge of the image is Neptune, next to a faint star. The planet was just about to disappear behind a balcony on a building when I took the shot. Although the magnification is low, it is still a good feeling to capture the most distant planet in the solar system. The light from it has traveled about 4 hours before reaching the camera sensor. Even with a good telescope, no surface details are visible. At my location, the astronomical seeing is not the best, and there is often turbulence due to heat from buildings below the line of sight. Neptune has a very special place in the history of science, since it was one of the triumphs of Newton's mechanics. The existence of the planet, its position and size, was concluded from calculation before it was confirmed by observation. Theories in physics sometimes make predictions of the existence of things before they are observed. Einstein's theory of relativity is another example, which makes a number of predictions of things that would later be confirmed. There is a lot to say about that, but that will be in a separate video. That was all for this time. I hope you enjoyed this video. Please remember to subscribe to this channel. I will make more videos about astrophotography, space exploration and other topics. I look forward to see you then. Have a nice day.